lesson, we will differentiate letters as constants. Let us start with the linear expression. We have fx is equals to mx plus c. In the previous lessons, we have learned that the first derivative is the gradient. Because this is a linear expression, we know that the first derivative would be equal to m. But when we differentiate mx plus c, we have m times 1, the exponent of x is 1, and in the exponent I subtract 1. C is a constant value, so therefore there is no variable, so it becomes 0 when I differentiate. And if I simplify, I have m times 1 x to the power of 0, which is simply m. How about the standard trinomial expression? We have y is equals to ax squared plus bx plus c. So in order to differentiate, I differentiate each term individually. So I have as the derivative 2ax plus b. So a is multiplied with the exponent of 2, and in the exponent I have 2 minus 1, which is 1. B is multiplied with 1, and in the exponent I have 1 minus 1, which is x to the power of 0, which becomes 1. C doesn't have any x's, and therefore it falls away. Let us find the derivative of the function v towards dt. Notice in this expression we have v equals to u plus at. So we have three different variables, but we want to differentiate only towards t. We see that there is no t next to the u, so it will become 0. We have a times t, so it's a times 1. The exponent of t is 1. And we subtract 1 from the exponent. Therefore, the derivative is 0 plus a, or only a. Now we want to differentiate towards p, where the expression is mp cubed minus p squared q squared plus r squared. So I'm going to apply the rule of differentiation on p only. Therefore, in the first term, I have 3m p squared, multiplying the 3 with m and subtracting 1 from the exponent. In the second term, I have 2p, so multiplying 2 with pq squared and subtracting 1 from the exponent of p only. Notice I'm left with q squared because I'm not differentiating towards q, only with p's. Our final term doesn't have any value of p, so it simply becomes 0. Therefore, my final differentiation is 3m p squared minus 2pq squared. Now we have two expressions. We have y is equals to 2x times 3 minus x, and z is equal to y over 2. And we want to find three different forms of differentiation. We want to differentiate dy dx, dz dy, and dz dx. Let us start with dy dx. So y is equals to 2x 3 minus x. If I multiply out, I have 6x minus 2x squared. Therefore, dy dx is 6 times negative 4x. So I simply apply the rule of differentiation on each term individually. And notice I'm taking the equation of y and I'm differentiating or applying the rule of differentiation on the x variables only. Now let us find dz dy. So I have z is equal to a half of y. So dz dy is simply a half. So I take the equation of z, that is where the dz is, and I want to differentiate the y's in that equation. So it's a half times y, and I multiply a half of the exponent of 1, and I subtract 1 from the exponent. So it's 1 minus 1, which is y to the power of 0, which will become a half. Lastly, we have dz over dx. Notice we have z is equal to a half y. We cannot find dz dx directly because there are no x values in the equation of z. Therefore, I need to replace the y with 2x 3 minus x, which was given at the start. And I'm finding z in terms of x. Now I multiply out, so it is 6x minus 2x squared. And if I simplify, I have z is equal to 3x minus x squared. Therefore, dz dx, now I can differentiate x's because I have x's in the equation of z is 3 minus 2x.